So this is a quadratic formula. This is section 12.3, and the other day we just kind of introduced it a little bit, and we said there was a song that the tune "Pop Goes the Weasel" can help you remember this formula. So here we go. Y'all sing it with me. X equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And the all over 2a is really referencing the fact that the whole top part goes together on the top of a fraction, and what people will accidentally do is they'll just sometimes put that square root part over the 2a, but it all needs to go all over 2a. So you're going to, when we're doing these problems, we're going to simplify the whole top first and the whole bottom, and then we're going to kind of look at can we simplify our fraction, okay? So let's start. I thought we would start with some problems that were a little later on in this section. So we're going to start with number 11. There's a video out there, but most of the problems on the video were not ones that I assigned this year. I actually cut down the assignment some. So number 11 is 7x squared plus 2x minus 2 equals 0. Now when you use a quadratic formula, there's some things that are similar to factoring. Do you remember when we factored, we had to get all the terms on one side and 0 on the other? You got to do that here too, okay? So if all the terms are not on one side, you move them to all one side and you get 0 on the other side. We usually try to make the x squared term positive. That's just called standard form anyway, making the x squared term positive, because we don't like to have negatives out front if we can help it, okay? All right, so here we go. One of the first things that you can do to kind of help yourself through this, since this does involve a lot of plugging in numbers, is let's first figure out what our A is, our B is, and our C is, because we see that that's what we got to plug into this formula. And if you remember, I can label this equation ax squared plus bx plus c. And what the A is the number in front of the x squared term. So what's my A here? It's good, 7. The b is the number in front of the x term, and you take the sign with it. So like b is in front of x here, but it's a plus b. So I look up here, this is a plus 2, so b is a positive 2. Had it been 7x squared minus 2x, then b would have been minus 2. So you got to be real careful to pull the plus or minus as your sign of your number, in other words. Now the C is the number on the end. What is my C going to be here? Negative 2, right. We want to take that subtraction sign and look at it as a sign of that, because I could write minus 2 as plus a negative 2 if I wanted to. That's really why C is negative 2 here. Okay, so when you're doing this, the biggest problem is people have trouble plugging in stuff. Anytime we've done PEMDAS stuff, it's been some of the harder stuff for people just because they just make mistakes. So here's what I do. I go x equal negative b, I make a space for the b, plus or minus the square root of b squared, I make a space for the b, minus 4ac, and every time I hit a variable, I make a parenthesis to plug it in, and then all over, so I draw the bar all under the whole thing, not just part of it, all over 2a. If you set this up this way, it can help you, because people get confused sometimes about whether they're supposed to multiply something or subtract it, and part of that comes from, like, if you start plugging in negative numbers, you could see where you'd get confused if you didn't have something to show you that you multiplied on part of this. So let's plug in our numbers and see if we can see where you might get confused. All right. So x equal negative b. B goes in this first parentheses, and b is 2. If you wanted to, you could say, hey, there's another b here. Maybe you just fill in all the b's where they go. You know, maybe that's a good way to do it. Then let's say, okay, we know we got some a's to plug in. So what was A? A was 7, and there was an A here, and there's an A on the bottom. So let me write it in there. I'll just kind of color code our numbers here. I used green to write my C anyway, so C is down here for a C. Do you see if I did not put that parentheses around that minus 2 that I might think it's 4 times 7 minus 2 instead of 4 times 7 times negative 2? You see what I'm saying? That's why these parentheses are such a good idea. Plugging in negatives in this thing gets people messed up a lot of times. It's just how people make their mistakes. So now that I've got it in there, this is stuff that you already know how to do. It's PEMDAS. Please excuse my dear Aunt Sally. If you remember, parentheses could be parentheses, but that means there's a couple of things inside the parentheses that need to be simplified. So I really don't have any parentheses here, but I do have a grouping symbol. Isn't this square root kind of like a big grouping symbol? Everything underneath it goes with it, right? So P can mean parentheses. It can also mean grouping symbols like square roots, and we have things called absolute values that we'll probably be looking at before the end of the year. So I'm going to do the part underneath the underneath the square root first. I'm going to go ahead and put -2 out here. Now under the bracket, what is, once I get under the square root, I still have to do PEMDAS again because now I got a bunch of other stuff. If I'm looking at that expression, we do the exponents first. So what's 2 squared? 4, so we got 4, and then now people do this second part a lot of different ways. Do you agree with me that 4 and 7 and -2 are being multiplied by each other? Some people say, I'm going to write my subtraction sign down, and so they would copy their subtraction sign down, and they would say, well, 4 times 7 is 28, and 28 times -2 is -56, so they would have minus 56. Here's what some other people do. This is what I do, actually. I look at that, I go, you know what, subtracting 4, isn't that the same thing as adding -4? So what I do is I say, well, I'm going to add or subtract something, but let me just multiply, and let me look at that negative as like the sign of the 4. I could say -4 times 7 is -28, and then -28 times -2 is positive 56, and I would write down positive or plus 56 that way. So some people actually copy the subtraction sign down and then mentally cover it up or cover it up with their finger, and they would have a subtraction sign there, and then they would multiply the other 3 numbers, and they would have had 4 minus 56, which is the same thing as 4 plus 56. You can choose how you like to think about that, whatever makes more sense to your brain. I know I'm supposed to do the whole top, and I know I'm supposed to do the whole bottom separately. Even though I'm kind of in the middle of a PEMDAS thing there, well, let me go ahead and just kind of copy the top over here. Let me not do what I was thinking. What is underneath the radical? What's 4 plus 56? 60, okay. So now, there's not a whole lot I could do there just for the moment. I could go ahead and simplify the radical, but we'll do that in a second separately. Let's go ahead and kind of clean up the bottom and bring it along. On the bottom, you got 2 times 7. We don't really need to think about PEMDAS too much there. What's 2 times 7? 14, okay. Okay, so I had -2 plus or minus the square root of 60 over 14. But do you remember that when we have radicals, we have to simplify them down to the simplest radical form? Let me go ahead and make a new slide and copy 2 plus or minus the square root of 60 over 14. You tell me if I copied it down wrong. All right, so we need to kind of simplify square root of 60 because it might be that this fraction reduces. This is a funky looking fraction, isn't it? By the way, this means there are 2 answers. One answer is -2 plus the square root of 60 over 14, and the other answer is -2 minus the square root of 60 over 14. Do you remember that when we have a square, that exponent of a 2 on our x tells us that there's probably 2 answers? And so there are 2 answers here. Now, I want to know if I can reduce this at all, and I think I can. So let me come over to the side and reduce the square root of 60, because I can reduce this fraction a little more. And this is the part where most people have some trouble, okay? If you remember, there's 2 ways to reduce the square root of 60. One way is to say, what's the biggest square that divides into 60? I think it's 4, okay? So I could say, hey, 60 is the same thing as 4 times 15, and the square root of 4 is 2, so I bring that on the outside, and I get 2 square roots of 15. That's one way to reduce it. Another way, if you don't like that way, if you remembered, was that you could prime factor 60. Let's say I say 60 is 6 times 10. Maybe I remember that fact. Then 6 is 2 times 3, and those are prime numbers. And 10 is 2 times 5, and those are prime numbers. So I could rewrite it in terms of its prime numbers, which would be 2 times 2 times 3 times 5. And you remember when I'm doing it this way, I'm looking for pairs of numbers, because the square root means I got 2 of the same thing, right? So I've got 2 2's. In other words, what is 2 times 2? 4. What's the square root of 4? 2. So I can bring a 2 on the outside, or I could say I've got 2 2's, bring 1 on the outside, or the square root of 4 is 2. And then I got 3 times 5 underneath still. They don't have anybody to go to the square root dance with. They're so sad. Can't go together because they don't match. So we would go ahead and put them back together now. Since they can't get out, 3 times 5 is 15. Either way, when I reduce the square root of 60, I get 2 square roots of 15. Okay, so there's 2 different ways to do that. So let me write that down. That's negative 2 plus or minus 2 square roots of 15 over 14. Now this fraction does reduce. We're starting with the harder ones, okay? So the ones you get at the beginning, I'm not sure if they're going to go this far, but I'm trying to pick the harder ones on purpose because you won't know what to do with them if I don't. Here's what I can do. There's 2 ways to explain this too, and I think what I'm going to do is I'm going to pick a way that maybe I think sticks with people better. If you look at the top, just the top, is there anything that divides out of negative 2 and 2 square roots of 15? Remember, I can't divide anything under a radical with anything outside of the radical. Do you see that I could divide out a 2 out of the top? I could factor out a 2 like a GCF, and that would be negative 1 plus or minus square root of 15. Okay? All I did was factor a 2 out. Will a 2 factor out on the bottom? Yeah, 14 is 2 times 7, right? So do you see that if I do it that way, the 2's would cancel out? Everybody kind of see what I did there? I took a GCF out of the top of 2. So I could write my answer, since the 2's cancel out, I could write it as negative 1 plus or minus the square root of 15 over 7. Now, this is going to get confusing. I would take this as an answer, okay? But I have a feeling the back of the book's going to write it a little differently. Do you see up front how I factored out the 2? You know, and they canceled out? What if I'd factored out a negative 2? You know what? Let's not. Let's just not. Let's just not. Let's not. Let's just leave this the way it is. All right. So there are 2 answers. I can write my answer like this. This is the way lazy mathematicians write it. But if we wanted to know what the 2 separate answers are, it's negative 1 plus the square root of 15 divided by 7, or negative 1 minus the square root of 15 divided by 7. Do you see why the lazy mathematician would want to write it with the plus or minus? To save his little itty-bitty hand all that painful writing. Y'all talking about sore muscles today. His muscles get sore from writing math problems. He's such a wuss. Okay.